Hello, so today we're going to be talking about vectors. So I'm going to draw your attention first to these definitions. So the first one is a scalar, and a scalar is something that has a magnitude but it does not have a direction. And then the opposite of this here, well, it's not quite the opposite, but the other one is a vector. It has a magnitude and a direction. So what does that actually mean? If we think about it in terms of distance, if point A is here and point B is over here, and point A and point B are 100 meters apart, and little Jimmy walks to point B and then back, and little Jimmy's right in the middle, so he walks 50 meters one way and then 50 meters the other way. So the distance that he's traveled is 50 meters plus another 50 meters, so he's traveled 100 meters, but he is right back where he started, so his displacement is 0. And that's because the displacement has a direction, so the direction matters, whereas in distance, the scalar, it doesn't matter. So coming on to adding and subtracting vectors. So we do this by going from nose to tail. So if this vector is, we'll say this vector is 4, and this vector is 3, then the resultant between them, we draw like that, and the way we find the resultant is just through Pythagoras, because we've just drawn a triangle. So 3 squared plus 4 squared is equal to 9 plus 16, which is equal to 25, which is equal to resultant squared. So then the resultant vector is equal to 5. And then what we can do is we can find the argument of the vector, or the angle. So if the angle is here, then the angle it makes to the horizontal, or to the vertical, is going to be the opposite over the adjacent. So tan of the angle will be equal to the opposite over the adjacent, and then the angle will be equal to the arctan of that. And I don't have my calculator on me right now. I probably should have it, but that's essentially how we do it. So whenever we're talking about resolving things to the horizontal or the vertical, if we have a grid and we have something at an angle of x, then to go from here to here, to find the horizontal of the angle x, all we need to do is do, let's say this has a magnitude of 5. All we would do would be 5 and then the cosine of x. So that would get our horizontal. So the horizontal would be 5 times the cosine of x. So in order to close the angle, we find the cosine, and then in order to start closing the angle, and then in order to open the angle, we find the sine. So the vertical component of this would be 5 sine x. Then just to add to that, if we had another straight line here, and let's say that this was 10 and the angle y was there, then to find the vertical component, which would be going down, it would be 10 and then the cosine of y. And that's because we are closing this angle, because the angle is here. If we want to open the angle to find the horizontal, then the horizontal would be going to the left in this case, and it would be 10 times the sine of y. So whenever we are given a force diagram, which we often are in physics, if we have something in the middle, and this is what our forces are going to be pulling upon, it'll often be given a mass. So if we have 5 kilograms, and then it'll sometimes be given a vector coming out here, and it will say maybe 10 newtons at an angle of 30 degrees, and then let's say we've got 20 newtons coming out to the right. So what we need to do here is we need to find the forces acting on this square in the middle. So the way that we do that is we draw a forces diagram, which kind of looks like this. You've got your vertical component and your horizontal component, which is a semicircle, but we'll just pretend that it's a line. So we've got 10 newtons coming through here. So that 10 newtons has a horizontal and vertical component, as we've seen with this vector and this vector. So in order to find the horizontal and vertical component, we just have to resolve the angle. So to find the closing of the angle will be the horizontal component. So that will be 10 newtons cosine, cos for close, of 30 degrees. And then there is also this 20 Newton horizontal. So we just add that. So the total going to the right will be 10 newtons. Sorry, I don't know why I've written. It's just 20 newtons going to the right, because that there is 20 newtons. And then this here, which is being closed, is 10 cos 30. So it's 10 cos 30 plus 20 newtons. And then to open the angle, we would find the vertical component. So it's going this way to open the angle, and to open it is sine. So we've got 10 newtons sine 30 degrees. And then we've got one more angle, or one more vector, which is the vertical component of the mass, which would be 5 kilograms times the mass due to gravity, the acceleration due to gravity, which would be 9.81. So 5 times 9.81 would be equal to 49.05, I think. So then we would end up having to find our total vertical component, and unfortunately I still don't have my calculator, and that would be probably going down because 49.05 is quite big, and then we'll be taken away. So here's our 49.05 from the vertical, here's the vertical, and then we'll be taking away our other vertical component, the one pointing up, which would be 10 newtons sine 30, and then we would end up with some vector going down, which would be 49.05 minus 10 sine 30, and that would be in newtons. Then going to the right, because we don't have anything to the left, so that's blank, so that's just 0. So going to the right, we would have 10 newtons cos 30 degrees plus 20 newtons. Okay, so then to find the resultant force pulling on the mass, we've got one going to the right and one going down. So we've got 49.05 minus 10 sine 30, and then we've got 10 cos 30 plus 20, and then we can just find the resultant in the same way that we did up here finding the resultant, where we just used Pythagoras' theorem. So we use Pythagoras' theorem, and then the resultant vector is going to end up being equal to the square root of the 10 cos 30 line plus 20 squared plus 49.05 minus 10 sine 30 squared. So once we've got that all worked out, you can put that straight into your calculator and find your resultant vector. So then all you would need to do after that would be to find the argument of the vector, and that would just be the tan to the minus x, sorry, not tan to the minus x, tan to the minus 1 of your opposite, which is 49.05 minus 10 sine 30 over your adjacent, which is 10 cos 30 plus 20. And that is how you would find, unfortunately I don't have my calculator with me, it's in my car, but that is how you would find your argument and your resultant vector's magnitude. Alright.